All right, college trigonometry students, we'll be looking at the third part of section 6.3, just a little discussion about similar triangles. And similar triangles come up in trigonometry from time to time. We work a lot with triangles in the trig class, so we're going to look at what we mean by similar triangles. So basically, similar triangles have these features. They have the same shape, but not necessarily the same size. The corresponding angles are equal, and the corresponding sides are in the same ratio. Okay, so this is an example. All of these angles are the same, and then the sides that correspond to one another would be in the same ratio. To test for similar triangles, this is something that a lot of times students don't know much about, it seems like, but if two corresponding angles are equal, then the triangles are similar. If two angles are equal, then the third side has to be equal. So we only have to know two angles to determine whether they're similar. If all three sides are corresponding sides are in the same ratio, all three sides we have a similar triangle then. And then if we have a side and an angle on a side, that just means you have a side, an angle in the middle of those two. And if those things, the sides are in proportion and the corresponding angle was equal, then you would also have a similar triangle. So I'm going to open up this applet, excuse me, and look at this. This is a kind of a nice way to visualize similar triangles, just what they are. So here is a triangle. I'm going to adjust these sides so it's a little bit easier to see. So that looks like a pretty decent triangle right there. You have angles 87.11, 65.77, and 27.13. You can see that. Now I'm going to create another triangle which is identical to it. And of course, these would be similar triangles. They match perfectly, although they don't seem like they line up exactly right. I think maybe I can somehow kind of change this somehow, maybe a little bit. Tilt it, but if not, it doesn't matter. There we go. So yeah, they match up perfectly, the exact same size triangle. But notice if I double the sides, like this is 4.2, I'm going to double the side on this. So the 4.2 turned into 8.4, the 2.1 into 4.2. But what I want you to notice is the angles did not change. It's just the proportionality of the sides was consistent. If I multiplied, this by 1.5, same thing's going to happen. The angles are not going to lose their measure, and it'll always be that way. If I wanted to triple this now I've tripled the sides, same thing happens, and if I slide this triangle and put it in, it kind of fits in there kind of nicely, so that the angles line up nicely and everything. So that's the thing on that is similar triangles can be formed by multiplying all three sides by the same number, and that won't change the proportionality of the sides and the measure of the angles. So what we're going to look at is just some examples of how to use a little bit of basic algebra to find like a missing side. So in this particular problem, first of all, we want to look at why are these two triangles similar to each other. Well, first of all, they do share an angle like that. And we're just assuming that these are similar in here. There's not enough information to really tell us much about that. But I am assuming these are similar triangles. We probably would find that these angles are congruent like that. And we usually, to show congruence of angles, we put an arc and a little bar through it like that. So what you're doing is you're just kind of making a proportion, and the sides are proportional. So when you make a proportion, there's a lot of ways you can do that. I'm going to relate the small triangle to the big triangle. And what I'm doing, when I make a proportion, I'm making two equal fractions. So it doesn't matter where we start. What we're supposed to find is side EF, and I'm going to call that my variable x. And this is just what I like to do. I like to put my unknown in the upper left-hand corner. It does not make any difference where you put it. So what I'm going to do is I'm going to match that up with the corresponding, let me do this like this. I'm going to put it like here. So that's on the big triangle, so X goes there, like that. Now, if I relate that to the small, let's actually do it like this, okay? There's so many ways you can do this. Let's just do the kind of the big in relation to the small, like that, okay? So what I'm going to do is, let's go like this. I'll put the X in the upper right-hand corner, and then that will correspond to the 6 like that. Okay, so I have that. Now what I'm going to do is find two matching sides, like this corresponds to that. So I will put the side of the big triangle on top and the little triangle on bottom like that. So you're being consistent. There's a lot of ways you can set that up. And now, typically, anytime we have two equal fractions, just an example, like if you had 1/2, you know that 1/2 and 4/8 are the same thing. If you cross multiply when two fractions are equal, they always end up having the same product. So we know that these are equal because similar triangles are proportional. So a good way to do this is just cross multiply. So we have 8 times x equals 6 times 24. You could certainly take your calculator and multiply by 6 by 24. I'm not going to do that. What I'm going to do is divide by 8. And then that's going to isolate the x. And see, the reason I'm doing that is just because 24 divided by 8 is 3. And then 3 times 6 is equal to 18. So what we find on this missing side is 18. And notice if I match this up, if I do 18 over 6, that's 3, but also 24 over 8 has the same proportion, like that. Okay, so you could set it up like that. You could also set it up like this. You could go, you can even go like this. 8 relates to 6 as 24 relates to x. You would get exactly the same answer if you did it that way. There's a lot of ways to put these things together. Okay, let's go to the next page. Now, this one is a little bit different situation. Now, this one right here, we're going to assume, they're actually on this one, I can show you why these two angles are congruent. So in geometry, vertical angles are always going to be congruent to each other. Vertical angles are on opposite sides of crossing lines. So we have that. Okay, we also have something that's called alternate interior angles, which is a nice thing to know from geometry. Alternate interior angles are also congruent to each other. And what we mean by that, if you have two parallel lines, these lines are parallel, then it turns out that this angle right here is the same as that. And we now have two angles that are congruent. So by what we call angle-angle similarity, we know that these two triangles you see in this diagram are similar triangles. You could also, it's unnecessary, but this angle right here is congruent to that angle because, and it's only because these lines are parallel. If they weren't parallel, they would not be equal to each other. So what I'm going to do on this is it corresponds like this. We're going to find side CE. Now I'm going to erase kind of all these little marks I put on here. So CE is going to be the X right here, and we're going to do that. So again, we need to match this up. So again, I'm going to put the congruence of the angles kind of like that. Those are congruent. These two are congruent. And these two right here are also congruent. That'll help you match the angle up. So what we're going to do is let's just do kind of the big triangle related to the smaller triangle. And again, what I like to do when I create my proportion, I like to put my variable in the upper left-hand corner. That's unnecessary. So that side actually corresponds to this side right here. If you look at the angles, we have the one with 3 symbols, the one with 1 symbol, that's the same as that. So that's going to correspond to 8. Now we just have to find another one. Now and the other one that matches up is this side, 7.2, is proportional with the 6 centimeters. So we could write this as 7.2 centimeters over 6 centimeters like that. So I'm taking the side in the big triangle related to the corresponding side of the small triangle, setting that up in a proportion. Okay, then again, you can cross multiply. So we know that 6 times x will be the same as 8 times 7.2. This time I'll take a calculator and just work out 8 times 7.2. And when I do that, I'll get 57.6 is equal to 6 times x. Okay, now I'm solving a basic algebra equation. I can divide both sides by 6. Okay, so that would give me what x is equal to. I can take my calculator to figure that out. So I just go 57.6, divide that by 6, and I did not do that right. Okay, let's try that again. 57.6 divided by 6 will give 9.6. Okay, and then that would be in centimeters. You need to put the units on that. So what this really means is it really means this. If you put these sides together, 7.2 over 6 is going to correspond to 9.6 over 8. That side it corresponds to that side. I tried to highlight them like that. And then if you did this on the calculator, if you took 7.2 divided by 6, you get that. And notice if you do 9.6 divided by 8, you should get exactly the same thing. So that's how you can tell that you're correct in that problem. Okay, so that will kind of take you through 2 examples. I'll have you go ahead and pause the video. I'll have you work on the 2 problems at the bottom of the page. And just come back and check your answers when you're done to see if you get these right. And then that will show you what you need to know in trigonometry for similar triangles. So go ahead and pause now. Okay, so if you want to check your answers and see if you did okay, you did not have to do it exactly the way I did it. You just have to set up a valid proportion. So the first problem I got 25 over 6. The way I did this is, we have kind of a small triangle, and that small triangle, of course, is this part right here. We have the small triangle, and then you have the big triangle, like that, and it corresponds like this. You have 5, and then the big triangle has a side of 5 plus 1 or 6, and then this is x, and that's 5 like that. So that's the correspondence. What I did was I did the small in relation to the big. So I did x over 5. That side corresponds to the 5 in the big triangle. Then I did 5 in relation to 5 plus 1 or 6. Then cross multiplied, solved the equation. And you don't want to get a decimal on these. You want to just get an exact answer. So 25 over 6 is it. You don't need to change that to a decimal because the decimals repeat. Okay, the next one, you were supposed to find both x and y. And the correspondence on this is like the example I did. These are parallel lines, which we usually represent like that. So the vertical angles are congruent. The alternate interior angles are congruent. So when I looked at x, x is here. That clearly corresponds to the 18. I decided to put the small in the numerator and the big triangles in the denominator. Then I found another pair that corresponded. So we have the 5 matching up with the 9. Okay, you can cross multiply that to get 9x equals 90. Divide by 9, you get x equals 10. So that's how that gets put together. If you look at finding y, now what I recommend is, the y corresponds in the big triangle with the 6. So here I just decided to put the big in relation to small. I just have a habit, I don't know why, of putting the variable in the upper left-hand corner. It does not make any difference as long as your proportion is valid. And then I just did this. I did the 9 would correspond to the 5. So I'm using the y and 9 in the big triangle, comparing that to the corresponding sides in the small triangle. Cross multiply, get 5y equals 54. Divide by 5, and then you just want to leave the answer as 54 over 5 like that. Okay? And that's how that goes. Just a couple of things that are worth mentioning on this with, I'm going to do something on my calculator here. So we ended up with x being 10, and we ended up with y being 54 over 5. So if you put all these things together, you would have 10 relating to 18. You would have the let's see, the 5 relating to 9. And then we would also even have this. We would have the 6 in the small triangle relating to the 54 over 5. Okay, well, it's pretty easy to see this. I mean, these things, this reduces to that. 10 over 18 reduces to 5 over 9. And then if you look at this thing right here, this is really 6 divided by 54 over 5. You divide fractions by multiplying by the reciprocal. And then if you went through and reduced this fraction, I think what you get on that is 6 goes into 6 one time, 6 goes into 54 9 times. So notice you get 5 ninths also. So every one of these proportions is the same as 5 ninths. So once you make that connection, then you really understand clearly, I think, what similar triangles are. Okay, hope that helps you with that. The main thing that you all need to know is what similar triangles are, how you determine if two triangles are similar. Typically, the most common thing is to look for two angles that are, the two corresponding angles are equal. And if you have two similar triangles, you want to be able to find a missing side by formulating ratios and proportions. Okay, hope that